you guys need to take days off school?
Grade 11, choice 1, a second half hour on the 24th of June.
Thank you. Okay, so look at this child. And overall, if you look at this child, it looks like a perfectly normal child, but in fact, there's lots wrong. So the first thing is what is called microcephaly, and that means a narrow head, and the cranium is smaller than it should be. What is that indicating? Brain is smaller than it should be. That makes sense? Okay, so the brain is not well developed at all. Short pulpable fissures. And a pulpable fissure is the distance between the inner corner of the eye and the outer corner of the eye. Okay, is shorter than it should be. And there's a reason for that. I'll explain that just now. A flat midface. So, like all this region here is flatter than normal. An indistinct fulcrum. So a fulcrum is these two lines on the upper lip. Okay? Correct scientific name for it is it's a fulcrum. Kids with fetal alcohol syndrome have a flat fulcrum. So they don't have those two lines there. They don't have Cupid's bow. Do you know what a Cupid's bow is? Where the lip goes like that. You know when you do lipstick? Other than you, I have, well, hey, I don't care. Let me not be discriminatory here. Lipstick. Okay, Cupid's bow. No Cupid's bow if there's no fulcrum. Okay, right? Thin upper lip. Micrognathia. What does micro mean? What does gnathia mean? Jaw. Jaw. Small jaw. Okay, so they've got this little funny narrow chins. Okay, short nose. In other words, very long distance between this thin upper lip and the end of the nose. Okay, minor ear abnormalities, small pinny. In other words, these things here that you guys tend to call ears, but they're not ears. This is a pinner. A low nasal bridge. That means that this part is very flat. So if the person tries to wear glasses, it's difficult to get the glasses to sit on there because the nasal bridge is very flat. So in sideways view, that part that you would always draw before drawing the nose is actually much flatter than it would normally be. And something called epicanthal folds, which I have to show you. These are folds on the inner and outer corner of the eye that are typical of Asian people, but in Asian people, it's not related to fetal alcohol spectrum disorder or fetal alcohol syndrome. They have it, it's genetic in them. But people who genetically don't have it, but the mother did drink while pregnant, they quite often have epicanthal folds. So here, for example, is a clinician trying to diagnose a child. Now, in the United States, there are very good reasons for diagnosing. In South Africa, we just, like laugh it off. But in the United States, they get benefits. Children who've got FAS, they get benefits. Like, for example, if they go to a normal school, they will have a teaching assistant. So they will have a person next to them through the lesson who actually reads to them or writes their answers or that kind of thing. They actually have benefits. So there's benefit in being diagnosed in the United States. So this clinician is trying to diagnose this girl. So here they've got a range of pictures. These are all the things that the clinician is looking at. Does this child fit this picture, or this picture, or this picture, etc.? And you can see that one. Very thin upper lip, very flat fulcrum, very short nose, because there's a long distance between the lip and the nose. Okay.
Ma'am, why would you have to diagnose? Can't you just go back to work longer?
Very often the mothers are not in a state to actually, firstly, often they won't admit it. Secondly, they've often given up the child. So if they're a person who's chronically a drinker. Very often they won't keep their kids. So it's very difficult to get a diagnosis because very often that whole thing is you meant to show a history of prenatal exposure to alcohol, and that's very difficult to get. Mothers won't admit, or mothers are not findable. Okay. All right, so this child, for example, looks like a really perfectly normal child until you start going no philtrum, short nose, thin upper lip, okay, very narrow chin, and short palpable fissures from the inner corner to the eye, to the outer corner, shorter than normal, if you look at it carefully. Okay, so here's a picture that shows an epicanthal fold, there and there. This one's on the outer corner is not as well developed. And then these very clearly show you a short nose, okay, thin upper lip, and a smooth philtrum. Short nose, no philtrum, but here the upper lip is quite normal, relatively normal. But look at the little narrow chin. Okay. These photos show you 3 different people, a series of photographs over time. So this shows you this person now, but as a baby, you could already see some of the features. And then as she aged, you could see some of the features quite well as well. So look here, short nose, thin upper lip, narrow chin. Same thing here. Okay. This is very much like that picture. Look at it. Narrow head across there. Look at the little chin, etc. So you can see ears pinny, lower than normal. You can see the epicanthal fold. You can see the low nasal bridge. And you can see that the head is flattened from side to side. So it looks like a really big brain because look how high this is. But the reason why it looks high is because it's so narrow. Okay, and a very flattened philtrum, very thin upper lip, and very short nose. On this little girl, all you can see is the short palpable fissures. So from the inside of the corner to the outside of the corner, very short. Okay. Now this is where it starts to become relevant to the work that you're doing at the moment. So one of the things that it does is it affects the brain very badly. Okay, so this is a brain from a normal child who died and they removed the brain. And this is a brain from a child who died but had FAS, same age. So you're comparing brains of same age children. Okay, look how much smaller it is than that one. Secondly, this is nice and symmetrical. Look at this side of the brain. It's not as big, and it doesn't have as many of those fissures. It's not as folded as this side is, or definitely as this and this is. So that's showing you that the brain is not as well developed as it should be. Okay, so the brain tissue is not well developed. And certain specific brain regions don't develop correctly, especially in the cerebrum, the cerebellum, and the corpus callosum. So if you've learned the functions of those things, then you know the implications of it. Okay. Failure of cells to migrate to appropriate locations during brain development. So what actually happens in the embryo? Certain cells develop in a particular place, and then they actually move to another place as the individual develops, and they perform a function there. And in kids who've got FAS or FASD, that doesn't happen correctly. Okay, some of the cells die. They have abnormal distribution of neurons and abnormal neurotransmission. Now this shows you 3 different brains. This is a normal individual. So this is the control. because it's a normal individual's brain compared to two individuals whose mothers drank when they were drunk. Okay, and what you can see is, look at the frontal lobe here. So compare from here to here, look at the frontal lobe. Look at this individual's frontal lobe. Look at this individual's frontal lobe. So remember I said to you the slanting. Okay, if you put that thing there, it would go almost straight up. So that shows you less development of frontal lobe, less development of frontal lobe. Can you see why the nasal bridge is low? Why that little part in which you put glasses is low? And it's low because there's no brain behind it there, or very less brain, to put it. So that region of the brain doesn't develop as well. Okay. All right. So if their frontal lobe isn't as well developed as it should be, these individuals can't plan, they can't organize, they can't sequence, and they can't think abstractly. So there's a really good book about somebody, a guy who adopted a little child, who he only realized when this child was like 16, that the child had fetal alcohol spectrum disorder syndrome. And he writes in this book about his pain as a parent trying to teach this child, that every single day he taught this child to tie his shoelaces. And he was 16 and he still couldn't tie his shoelaces. He could not logically dress himself. So you know when you get up and you get ready for school, there's a certain specific sequence. You don't put your shoes on and then try and put your socks on. You don't put your trousers on and then try and put your underpants on, etc. This child could not get it. Even if the father put everything out in sequence, this child just could not get it. That you start there and you work your way through. And this is exactly what happens here. In fact, the child, when he was about 24, died. And the reason why is he stepped out in front of a car. Because there was no logical, if I'm going to step across the road and I can see a car coming, I can judge how far away it is. But they can't judge. They can't judge. So he didn't know that it was actually closer than he thought it was, and he was killed as a result of that. Poor judgment, poor problem solving and reasoning, slower and less efficient processing of information. And remember, we've spoken about the corpus callosum as being this little band of white tissue that is so important with connecting the two halves of the brain. So this individual has a poorly developed corpus callosum. This one doesn't even have a corpus callosum. Okay. Cerebellum, for coordination. This one's got this is the normal. This individual seems to have quite a good cerebellum, but this one's doesn't have folds as it should have. And it's flattened across the top, the edge. It's not as well developed as this one is. Okay. So what are the variables that affect the damage caused by prenatal drinking? And this is all to do with, there are a lot, and they're so fascinating. The timing of exposure. So if you look at when the different parts of the body develop in a baby, in an embryo. So this is from week 1, okay, and it becomes, then it becomes week 238. And the scale is not constant, but it doesn't, there's a reason for that. And what they're showing is during the weeks 3 to week 16, is when the central nervous system develops. So if a mother drinks in those weeks, it's going to affect the central nervous system. If the mother's past those weeks and she drinks alcohol, it's less likely to affect the central nervous system. Okay, the heart, the upper limbs, etc., etc. So there are different times when different parts of the body are developing. So the timing of exposure relative to the development of the fetus. So different organs are developing at different times, and at some stage of the game, certain neurons are vulnerable, and it depends on when the drinking occurs. Secondly, and this makes good logical sense, the frequency of prenatal exposure to alcohol. So how many times did the mother drink? Okay, and when I say drink here, I'm not talking about getting drunk as a skunk. I'm talking about 1 glass of alcohol. Okay, 1 glass of alcohol can do this. Doesn't matter what a doctor says. That should be volume, because you know you're not allowed to say the rude A word. The amount of alcohol, the volume of alcohol consumed per bout. Obviously, the more alcohol consumed, the worse it gets. Very interesting, the health status of the mother. The worse the health status, the more it affects the child. Okay. Genetic makeup of the mother and the child, the embryo, fetus. Certain genetic makeups make a child more likely to get affected. And then this is fascinating. The number of children, I think it is. The number of children the mother already has. The more children that mother has had, the worse it is for a child. So if she does it with child 1, it's not as bad as if she does the exact same behavior with child 4. Exact timing, exact volume of alcohol drunk, etc., etc. It's going to be worse for child 4. And they cannot explain this. Nobody knows why. So there has been research done in the United States, but they don't know why. The older the mother, the worse it is. Okay. So what actually happens? Cognitive disabilities, in other words, thinking disabilities. To the extent that an individual might be defined as having mental retardation. So you guys do know that an average IQ is about 100? Okay, right. It can, some people are not affected. Their IQ can be up to 130, even although the mother drank while pregnant. But it can be as low as 30. Now this is a person who's going to require care for life. Learning disabilities, developmental delays such as with speech, with ability to tie shoelaces, toilet training, etc. Potential academic ceiling, in other words, there's a limit to how far they're going to get in school. Memory and processing problems, attention deficits. They have problems with learning, they have problems with memory, they have problems with visual spatial functioning. So that is difficulty understanding the spatial relationship between various objects. And this explains why that child was run over. Okay, because he couldn't judge how far something was away. Higher order cognitive processes such as planning, organizing, sequencing, abstract thinking results in problems with routine activities, even such simple thing as getting dressed. Ability to maintain attention, huge problem. Motor control, in other words, control of movements, coordination of movements, bad. Okay. Impaired social functioning, and this makes sense because they don't have the correct judgment skills. So disturbed behaviors, psychiatric disorders are common. So in one of the studies, 94% of those studied had problems, health problems, mental health problems, including 52% of these had depression. Psychosocial behavior, anxiety, poor social skills, their interactions with others, their manners were bad, and they had low academic achievement. Okay. Things like disrupted schooling, expelled from school, trouble with the law, convicted of a crime, inappropriate sexual behavior, alcohol and drug problems, employment problems, unable to live independently. They had to be in care all the time. It's believed to affect at least 10 in 1,000 children born in the USA. Now this is the scariest thing. In a study done in 4 areas in Gauteng in 2003, 22 7-year-old children out of the 850 examined had FASD. So it's much higher than in the States.
We were born in 2003.
Arrest my case. One study done in the Western Cape found between 40 and 46.4 per 1,000. Look how many more were affected. Why in the Western Cape? And a lot of the workers are paid in alcohol.
Really?
Yes, it's illegal. It's called the DOP system, where they actually give the workers on a Friday some alcohol and as partial payment, and it's illegal. And a lot of the children in those areas, fetal alcohol problems, you can see. Another study found that 25 in every 1,000 7-year-old children tested in Soweto had a severe form of the syndrome. Now, do you realize these? It's what I'm telling you about, is that these are people who have problems with the law because they have poor judgment. Okay. That's that. I thought you might be interested.
That's crazy.
Gives you something to think about. Okay. Right, ladies and gentlemen, have you got any questions to ask? The class and the online class.
Now, with like things like dyslexia, like where does that come from?
Oh no, I have no idea. So, I really, really don't. I don't know whether it's not something I've ever gone and researched. So I don't know. I don't think it's genetic. I'm not certain.
I think it is genetic.
Oh, is it?